When we learned how to do numerical long division, this was a long time ago, possibly third grade, second grade. We talk about dividing a smaller number into a larger number. And what we do here is, if you look at this example, we are dividing 21 into 672. And we start by doing division. We divide 21 into 67, and it divides into 67 three times. Then once we divide it in three times, then we turn around and we multiply 3 times 21, and that gives us 63. Go ahead and subtract, and we have 4, and then we bring down the 2, and then we again divide. 21 divides into 42 2 times. There's my 2. And now that I've divided, I multiply. 21 times 2 is 40, and then subtracting that is 0. So that is numerical long division. And what you'll find out (3x). So I can multiply, divide 2x. Sorry, I divide 6x squared by 2x, I get 3x. So I am going to go ahead and take 3x, and I am going to multiply that by 2x, and that's going to give me 6x squared. Then I'm going to take that 3x, and I'm going to multiply it by 1, and it's going to be plus 3x. Now that I've done that, I'm going to go ahead and divide. And 6x squared minus 6x squared, of course, is 0. And then 7x minus 3x is going to be 4x. So I'm going to carry that down, and I'm going to bring my 2 down, so I have 4x squared. And I'm going to divide 2x into 4x. So 2x, 4x, and that is going to give me a 2. So 4x divided by 2x is 2, so I'm going to bring my 2 up here, and I'm going to do the multiplication now. 2 times 2x is going to be 4x, and then 2 times 1 is going to be 2, so it will be 4x plus 2, and go ahead and divide that, and guess what? I am going to get 0. So 2x plus 1 is an even factor of 6x squared plus 7x plus 2. So yes, using this long division does help us with our factoring if needed. Now let's look at the lesson now that you've seen where we were going from long division, numerical long division, into polynomial division. Okay, so let's get back to our notes over here, and 5-4 dividing polynomials, and we use synthetic later on. That's a simplified form of division, and I'm going to take and use my polynomial division, and I'm going to use long division to divide x plus 7 into 3x squared minus 29x plus 65. And I'm going to go ahead and set that problem up like we did before. Okay, checking for factors. As I said before, if you can do the division and get no remainder left over, then that proves that that is a factor. And what they're asking you here is checking factors, and they want to know is x to the fourth minus 1 a factor of this larger p of x function, x to the fifth plus 5x to the fourth minus x minus 5. So in order to do that, what we can do is we can go ahead and set it up into long division. And I know that that is going to be x to the fourth minus 1 divided into x to the fifth plus 5x to the fourth minus x minus 5. And if for some reason it wasn't set up properly, you would always want to make sure that you're set up in standard descending degree. And the first thing I want to do again is going to be divide, multiply, subtract, and repeat. So I am going to divide x to the fifth by x to the fourth, and that, in case you need to see that, x to the fourth is going to give me an x. So it goes in x times. Then I'm going to multiply. I'm going to multiply x times x to the fourth, which is going to give me x to the fifth. And again, I'm going to multiply x times -1, and that is going to give me negative x. And I'm going to go ahead and do my subtraction. And in doing so, let's go ahead, that cancels out to 0. And I'm going to bring everything down, and I'm going to bring down 5x to the fourth. This cancels out to 0, and minus 5. Let's see, so I'm going to do my division here, and I'm going to divide 5x to the fourth by x to the fourth, and that goes in 5 times. So I am going to plus 5. I'm going to multiply 5 times x to the fourth. So it's going to be 5x to the fourth, and then 5 times -1 is going to be minus 5. And go ahead and do my subtraction, and my remainder is 0. So yes, x to the fourth minus 1 is a factor of p of x. So, because there's no remainder left over after our division problem. All right, let's look at this next example. We're going to be doing division, but we are going to use synthetic division. And in synthetic division, this is going to simplify our long division process, and we are going to be dividing by a linear expression. So let's see, we will do our division, and the way this is set up, we're only going to be worried about our coefficients here. And I know that I have 0x squared. Or I tell you what, let me not skip ahead like that. And what I will say is I can rewrite this in standard form. Minus 0x squared minus 57x plus 56. When dividing synthetic, we want to make sure that we're accounting for all of our degrees. So since there is no second degree there, we need to make sure we put it in there. And I'm going to go ahead and set this division problem up. And I'm going to divide by 7. And if you think about it, what is x equal to? Well, x minus 7 is equal to 0, or x is equal to 7. So that's what I'm going to divide by. I'm going to divide by that 7. And like I said, I'm only concerned about my coefficients. My coefficient is 1, 0, -57, and 56. So I am going to divide into 1, 0, 56. And what do we do here? The form is very simple once you learn the pattern. We are going to carry one number down. 1 comes down, and then we are gonna add down. We are gonna multiply at an angle. So 1 times 7 is going to give me a 7. Then I'm going to add down again. Times 7 is going to give me a 49. I am going to add down. -57 plus 49 is going to give me a -8. And again, I'm going to add across. So I have negative 8 times 7 is going to give me a negative 56. I'm going to add down, and that gives me a 0. And this 0 is actually going to be my remainder. But what happens here is, now since we technically divided by x minus 7, well, that means we divided by x, so we are going to decrease our degrees. So this is going to be 1 x squared plus 7x minus 8, or x squared plus 7x minus 8. And that is going to be the remainder, or that is going to be the factor. And of course, we knew that we had the factor out here of x minus 7. Again, no remainder. Remainder is 0, so it is a factor. Taking this next problem, and we're going to use synthetic division to solve a problem, and we may need to do a couple of more synthetic division examples here in a minute, but I need to say that this expression right here expresses the volume in cubic inches of a box, and its width is x plus 1 inches. Well, I know that volume equals length times width times height. So I know that volume is length times, and they told me my width is x plus 1, and then I don't know my height. And what are the dimensions of the box? Well, I know that if I divide the entire expression by the entire volume by x plus 1, I will divide the width away. So again, x plus 1 equals 0, or x equals negative 1. So I'm gonna divide by negative 1. That's the value of x. And looking at my equation, I have all my degrees accounted for, 3, 2, 1, 0. So my coefficients are of x to the third is going to be 1, then 6x squared, then 11x, and 6. All right, there are my coefficients for synthetic division. Remember to add downward. That's going to be 1. I'm going to multiply across, so negative 1 times 1 is negative 1. I'm going to add down again. That becomes 5. Multiply across, that becomes negative 5. I'm going to add down again. That becomes 6. Multiply across, and that is negative 6, remainder of 0. So it is a factor. We started off with x to... Okay, and what I've done is I've gone ahead and rewritten here that once we divided in that width, we came up with x squared plus 5x plus 6, and then I was able to do some trinomial factoring here. Simple trinomial, what were the factors of 6 that added up to 5, and I determined that it was x plus 2 and x plus 3. So now I can say, hey, I know my width was x plus 1, and then x plus 2 and x plus 3 could be length or height. It does not matter which one is which, but that is going to be the factored form, or that is going to be the dimensions of the box. Let's see. Now, evaluating a polynomial using the remainder theorem. Well, this function notation means p of negative 4 equals what? Well, whatever your remainder is, once you do your division, that is going to be the value of p of negative 4. So let's see, let's set this up for synthetic division real quick. And you'll notice that when I wrote this, I have 1x to the 5th, I have negative 3x to the 4th, negative 28x to the 3rd, 0x to the 2nd, 5x to the 1st, and then 20. And as I do my synthetic division, remember we are going to add down, and I'm going to add down, add down, multiply across, so I have 1 times negative 4 is negative 4, add down again. I am going to have negative 7, multiply across for a 28, add down again. 0 times negative 4 is 0, add down 0 times negative 4 is 0, add down 5. Okay, and then 5 times negative 4 is going to be negative 20, and our remainder is 0. So it looks like p of negative 4 equals 0, which means it's a root. And in this case, if I go ahead and rewrite my equation, I know that my degree of my result is going to be 1 lower, so I should have instead of x to the 5th, I'm going to have x to the 4th, so that's going to be x to the 4th minus 7x to the 3rd plus 2x to the 0 plus x to the 0 and plus 5, or x to the 4th minus 7x to the 3rd all right. Look at me messing up here by the numbers. That should be 0x to the 2nd, 0x to the 4th, sorry. And of course that's going to cancel out, that's going to cancel out, and that's going to be plus 5. So there you have it. Remainder theorem, whatever my remainder is would be the output. So if you put negative 4 into that function, your output is going to be 0, and that is the resulting factor.